All right, a quick example here. They give us a degree 3 polynomial. The a and c values, as you see them kind of throughout the polynomial, are constant terms. And what they want us to do is they want us to fully factor this expression, given the fact that a, c, and these as well are constant terms. You'll notice here, if I factor an x squared out of here, we'll be left with an x minus a. And if I factor a minus 2c out of this expression, we'll also be left with an x minus a. So that's kind of the hint that factor by grouping is going to work in this situation. Let's go ahead and do that. So I'm going to factor out an x squared, leave me with x minus a. Here I'll factor out a minus 2c, also leave me with x minus a. Now we have our common factor here, so that'll be factored out, leaving us with x squared minus 2c. We can now factor this further. You see I have my x minus a, and I can force a difference of squares on this by writing this as the square root of 2c quantity squared, and then you can go ahead and do your difference of squares. You get x minus a, x minus the root of 2c, and then x plus the square root of 2c. So you can see here that this polynomial degree 3 has roots at a and plus or minus the square root of 2c. Let's take a look at another way of tackling this problem. So now let's take a look at this example, same examples we were doing before, but let's suppose you did not see the factor by grouping. So I did not see I could factor out an x squared and a minus 2c here and do factor by grouping to break this polynomial up. Let's suppose you want to go through synthetic division to try to find a root of this polynomial. You'll notice by the rational root test, which we've talked about, I'll link the rational root test in the top right-hand corner. If you missed that lesson, that should appear there for you to recap. But essentially what the rational root test is going to tell us that if this polynomial has a rational root, it's going to be a factor of my constant term. My constant term in this case is 2ac. So if a rational root exists for this polynomial, it will either be... So you'll notice here, using the rational root test, we have a complete list of rational roots. If my polynomial does actually have a rational root, it will be one of these. Now there's a ton to try here, but you can eliminate some of these just by going through. You'll notice if I were to use, let's say, 2ac, you're going to get a cubed and c cubed. And again, subbing that in to either of these expressions here, you'll never get the c cubed that you want. So that one will not work. And for a similar logic, ac won't work. Likewise, if I put a 2c into here, you'll notice I'll get a c cubed here, and I don't get a c cubed here or here. So that we won't get cancellation, so that one will be out as well. Taking a look at the 2, if I put a plus or minus 2 into this expression, again looking to find a root, you'll notice that this will just generate, x values will just be numeric, which again won't create a combination of AC, right? If I put a 2 into here, you're going to get 8, 4, and then 2 times 2 is 4, but you won't get an AC. So again, this will eliminate that option. So we've knocked it down to a bit of these already. So let's go ahead and try A and see if A is a root. I'm going to do synthetic division on this. Doing synthetic division, we get the following. And you'll see here, doing synthetic division, right away, we get a remainder of 0. So again, with a little bit of observation, I eliminated 8 of these options, and we were down to another 6. I got lucky and the first root had worked. So now that we have that, I can break this down a bit further. This polynomial will now factor into x minus a times, this is now degree 2 polynomial, so it's going to be x squared minus 2c. And continuing this up here, you're going to have your x minus a, and we can factor this into x minus the root of 2c times x plus the root of 2c. And now our polynomial is fully factored. So again, here's another example approaching the question, same question, not doing the factor by grouping, going ahead and using the rational root test, finding the list of possible rational roots, and trying synthetic division until we break one of these polynomials down. A lot more work, but just to show you that both methods will eventually yield the correct answer. Thank you.